Hey everybody, Matt Morgan here. In this lesson we're going to go through the examples in Wiley problem 14-30. They're spontaneous redox reactions. So we'll talk about how to solve spontaneous redox reaction problems. The examples we'll go through are bromine and hydrochloric acid, sodium and aluminum chloride, iron and lead 2 perchlorate, oxygen and hydrochloric acid. Finally, we'll do fluorine and water. So we'll go through all these examples, we'll show how to solve them, and more importantly, how to input your answers into Wiley so Wiley marks them correct. So when given a reaction, the first thing you want to do is determine the half reactions. Sometimes that's easy, sometimes not so much. After you determine the half reactions, draw arrows on table 14-1 that indicate the half reactions, specifically the direction that the half reactions are going. Remember, when solving these problems on the assessment, you will be given table 14-1. Connect the arrows head to tail. If the loop runs clockwise, the reaction is spontaneous. If the loop runs counterclockwise, the reaction is not spontaneous. So let's work those examples. The first one, all it says is liquid bromine is added to an HCl solution. So bromine is one of the 7 elements. They exist as diatomics. So what you're looking for is not just Br, but you will write Br2. Here's those 7 elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I remember this because if you look on the periodic table, they kind of make a 7. Of course, you got to move hydrogen over, but if you do, it makes a 7, and those are all the diatomics. There's our half reaction. Table 14-1 only lists one with bromine. So the other reactant presents a problem because HCl is a strong acid. When that goes into solution, we have H plus and Cl minus ions. So which ion is going to be in our other half reaction? So we know that liquid bromine is gaining electrons. So our other half reaction must have the element losing electrons. HCl, or H plus, has no electrons to lose. It's just a proton. So H plus cannot be our other half reaction. Cl minus can lose electrons, so our other half reaction is 2Cl minus in equilibrium with Cl2 plus 2 electrons. So we draw arrows on table 14-1 to represent those 2 half reactions. The bromine half reaction goes from left to right. The chloride half reaction, losing those electrons, goes from right to left. Let's look at that. There's our bromine. There's our chloride losing 2 electrons. We connect head to tail, and we see that that is a counterclockwise motion going against the direction that analog clocks go. Counterclockwise, non-spontaneous. So there will be no reaction, but if you just type NR into the equation editor, Wiley will mark it as incorrect and not give you any feedback. What they want is to say Br2 liquid plus HCl aqueous, because they said liquid bromine is added to an HCl solution. You do your arrow, and then from the drop down NR. Be sure to include the states and NR from the drop down menus. If you try to type in parentheses or type in NR, it's not going to accept it. So let's look at the next example. It says sodium metal heated with solid aluminum chloride. So let's look at the half reactions. Sodium metal, once again, pretty straightforward. Sodium loses an electron to become Na+. The other given reactant, AlCl3. So we've got to choose once again like before between Al3 plus and the chloride ion. We know sodium is losing an electron. So the other half reaction has to gain electrons. The chloride is not going to gain anymore. We don't have a Cl-2 ion. So our other half reaction must be with the aluminum ion. That half reaction from the table is Al3 plus, gains 3 electrons, and we get aluminum. The sodium half reaction goes from right to left, and the aluminum half reaction goes from left to right. Let's look at that on the table. There's our sodium. Sodium's on the bottom there, going from right to left. 2 above that is the aluminum, going from left to right. Connect the arrows, head to tail, and we have clockwise motion. That is a spontaneous reaction. Now to put it in Wiley. Here's our half reactions. The reaction is spontaneous. Now we have to balance the equation. Notice sodium loses 1, aluminum gains 3. And all reactants and products need to be solid. Here is what Wiley is looking for. So 3 sodium metals solid plus aluminum chloride solid goes to solid aluminum plus 3 sodium chlorides. Now if you're asking how do we get everything in the solid state, yeah, it's kind of tricky, but this is what Wiley is looking for, because if we were to have aqueous solution and we add sodium metal, the water is going to react as well. So for this reaction to occur, everything has to be in solid state. Let's look at the next example. Iron placed in a lead perchlorate solution. Half reactions, the iron half reaction. So if you see the pattern in these examples, one of the half reactions is straightforward, and we can deduce the other half reaction from the one that's easy. So iron loses 2 electrons, becomes iron 2 plus. That's the only one on the table. So the other half reaction, is it going to be lead 2 plus, or is it going to be perchlorate? Well, the perchlorate ion is the conjugate base of the strong acid perchloric acid. Those conjugates of the strong acids are spectators. They don't take part in any reaction. So there's no listing for perchlorate either. So our other reactant has got to be lead 2 plus. So our half reactions are iron losing 2 electrons, the lead 2 plus gaining those 2 electrons. Put those on the table. There's our iron going from right to left, the lead going from left to right. We connect head to tail. We get a clockwise motion, a spontaneous reaction. Let's put it into Wiley. So it says iron placed in a lead 2 perchlorate solution. There is our reactants. Iron solid, aqueous, lead 2 perchlorate. So we know that the perchlorate is a spectator. It will associate with the cation. So we have iron solid, lead 2 perchlorate, aqueous, giving us lead solid and iron 2 perchlorate. Once again, aqueous. All right, let's look at the next example. Oxygen gas bubbled into an HCl solution. Our half reactions. Hey, oxygen, there's only one that has oxygen, and there it is. Now we've got our same situation we had before. HCl, is it going to be H plus or is it going to be Cl minus? There's our oxygen half reaction. It gains electrons. So the other half reaction must lose electrons. H plus can't lose, and we know chloride can lose electrons. So we see 2 chlorides losing 2 electrons to become Cl2. There's our other half reaction. So we put those on the table. Oxygen going from right or left to right. Just above it is the chloride going from right to left. Connect head to tail. we see it is a counterclockwise loop. This reaction is not spontaneous. The answer Wiley wants in the answer window is O2 gas plus HCl aqueous goes to no reaction, NR. This problem has one more example, fluorine gas added to water. The half reaction for fluorine, F2 plus 2 electrons, goes to 2 fluoride ions. So we see 2 entries for water on the table, but only one of them has water losing electrons. Remember, fluorine is gaining. Our other half reaction must lose. And there it is. 2 waters go to O2 plus 4H plus 4 electrons. We put that on the table. Fluorine going from left to right. Our water going from right to left. Connect the arrows head to tail. That is a clockwise motion. This is a spontaneous reaction. Now we got to put our answer into Wiley. There's our half reactions. Like before, we want to make sure it is balanced. Notice that the fluorine gains 2, but 2 water molecules lose 4 electrons. So what we've got to do is multiply the fluorine times 2. And we're not quite finished because hydrofluoric acid is a weak acid. It exists in the molecular form. So what they're looking for, 2F2 gas plus 2 water molecules, and water is a liquid, goes to O2 gas plus 4HF aqueous. Be sure to combine the H plus and the F minus and make that aqueous. So that was a lot of problems. The concepts are important. It was a little tricky maybe putting the answers into Wiley, which is why I went through all the examples. Good news is not a lot of math involved for this type of problem, but you have to know the concepts. So practice these problems, and as always, contact your course mentors if you have any questions.